anyone have a question that they would like to ask one of our speakers? Thank you.
Thank you all for your presentation. So Dr. Broglet?
Yeah.
So in the trends you detailed that were about the minimum daily temperature, is there a way to apply that and see the trends with the maximum daily temperature, or is that something that's not as often like tracked?
Oh yeah, you can definitely do that with maximum temperature. I just, yeah, you can do that with maximum temperature, but I focused on minimum temperature for this particular presentation because it's something that's changing more rapidly and more profoundly, at least here in Florida, and actually over a broader region overall. And it's of somewhat greater interest at this point. Yep.
Yes, please.
I have a question for Dr. Wing. I think maybe even less than 10 years ago, the expectation was that there would be, because as the temperature warms moving away from the equator, that there would be more tropical cyclones, but they might not be more intense. And you're saying now that it's really the opposite. The intensity is pretty sure to increase, but the number isn't going to change necessarily. Is that a recent?
So we've had the expectation that tropical cyclone intensity would increase from theoretical grounds since the 1980s when this theory was developed. So that's not new. In terms of the number of storms, as I said, that's a very uncertain prediction, and it has in some cases been evolving over time. One thing that I didn't mention is that you're right that you're getting warmer temperatures further away from the equator than we do now, which could expand the area over which we might expect tropical cyclone activity, or we might expect that where tropical cyclones either impact the most or have their strongest winds, that could occur in regions further poleward or further north than in the northern hemisphere than they do now. And so at any given location, you could have an increase in TC activity, and these are global trends I talked about as well. Regional things are very different, but we do see evidence that over the last number of decades, the latitude at which storms reach their maximum intensity is occurring further poleward. And that is concerning because it means that areas which historically perhaps haven't had much tropical cyclone activity could be at more risk in the future, and of course might not have infrastructure that's as well adapted to tropical cyclones or the local knowledge on how to handle them. And so that is something concerning. But as I said, I wouldn't personally put a lot of stake in the prediction that tropical cyclone frequency will do anything in particular right now, just because we don't have the theoretical expectation, and reasonable models and methods say different things on that answer. So our best guess is about no change or a global reduction, but regionally that could be very different, and it's overall uncertain. But the intensity prediction going up, that's pretty solid.
Yes.
Yeah, just not so much a question, but a comment on this conversation. Our own Jim Elsner published several years ago that the most intense tropical cyclones are indeed getting stronger in the historical record. So this idea that intensity is likely to increase is not only supported by theory and by modeling, but also has support in the historical record itself. So that even strengthens that argument.
Yeah, that's a good point. Although I would note that there are evidence historically for those increases in tropical cyclone intensity is strongest in the Atlantic. It's less certain in other regions of the world. And given various different modes of variability in the Atlantic, well, I think we expect that it's consistent with a climate change signal. It's difficult to completely attribute it to climate change, but you're right that evidence is consistent with our expectations for the future.
Yes.
So I have a very minor technical question about the connection between storm surge and sea level rise. I mean, I understand that given the sea level rise, the end result of the storm surge would be higher than it is now.
Right.
But are we talking about also a relative increase in sea level rise? Because the baseline as the sea level rises is higher. As if you put the storm surge on top of that, will that be higher also? Or I don't see any physical reason why it should be
So
the
it's
case.
sort of just saying that, so let's say that the hurricanes don't change at all in the future climate, and you would get the same amount of additional water than you would now. But that additional water is going to be on top of a sea level that is already
Yes.
higher. And so the flooding that you get from it could be worse. So for example, right now there might be a seawall that's 9 feet tall, and maybe the mean sea level below it is at, or where the water is 9 feet below that. And so if you have a storm surge of 5 feet, that's no problem. Your wall stops it. But if your sea level goes up such that now that wall only has clearance of 4 feet, and you put that same 5-foot storm surge, all of a sudden you're going to flood. So that's what I mean about the impacts getting worse.
Okay, thank
And of
you.
course, there's room for us to adapt to that, but
Right.
yeah.
Yes.
I have a question for all three of you. I guess how much does something need to change? Like how much degrees in temperature, in the power of storms or in the thickness of shells, and for how long of a period of time do you have to see that for it to be statistically significant and that you can talk to the public about it and say that this is a problem that we need to address?
That's a really hard question. That's actually sort of at the core of why scientists are so bad at communicating to the public. And why I have like a stack of books in my bedroom that's like how to talk to people about climate science. But I mean, I think we're already seeing really big changes, and I think that's why there's been sort of a surge, maybe in the last decade, of people reading books like that and trying to get the word out. But yeah, that's a complicated question, but I think we're there where these are problems, and I think problems that at least in Florida people are talking about whether or not they call it what it is. Yeah.
And I would just add to that by saying that in general, with climate change, when you can see a signal, it depends on, you can see your signal sooner or later in different things. And so we have seen increases in sea level rise and global temperatures and extreme precipitation rates and other things like that. Other things that we expect to change, maybe we haven't seen a signal yet because perhaps those factors are less sensitive to temperature, and so you need a bigger temperature change to see a response. Or there just could be more natural variability or more noise in your field, and so you need a bigger force signal to rise above that noise. And even for temperature, it depends a lot on where you look. So if you look at regional temperature change in the mid-latitudes, so like New York, like that kind of belt, there's a lot of variability in temperatures in that part of the world. And so in most of those kind of places, you haven't seen a robust, unambiguous warming yet. But in the tropics, for example, where the variability in temperature is much smaller, it's easier to detect a change, and those changes have been detected. And so there's a whole field of climate science known as detection and attribution, which studies, both how changes, how we can detect changes and whether or not they can be attributed to any sort of forcing. But they also just study the science of exactly that question: when can we detect the signal? And they study things what are called fingerprinting methods, where it's not just looking at the amount of signal, but to see if the pattern is what you expect. So, yeah, it's our understanding of it is certainly evolving, and unfortunately, we can't just like, oh yeah, after 20 years we can see this. It depends on what you're looking at.
One more. To answer the question.
Oh, I was just gonna say, I'm just gonna echo the idea that, yeah, it depends. And it's not just the change in mean behavior that you gotta look at, it's also the change in variability and whatever variable we're looking at. So, with temperature, if you think about like a, normal distribution or like your typical bell curve, if temperature's increasing, that bell curve's gonna shift to the right. So not only is your mean shifting to the right or getting higher, your variability gets into higher zones too. And often we're especially concerned about the tails of that distribution. So for looking at like maximum temperature in Tallahassee, right now at the very tail of that distribution on the right, like 100 to 105 for like maximum temperature during the day, it might be near the right end of that distribution, but maybe under further warming, that tail moves to closer to 110 or 115 degrees. I'm just throwing numbers out there, but that's what we're especially concerned about.
You had a question?
Yeah, I had a question for Dr. McCoy about the applicability of your research to oysters, Gulf oysters, and, thinking about the fate of oysters in the Gulf. I know we're looking at sea level rise and the effect that affects salinity and, increased predation by oyster drills and things like that. But I wonder, is there any research in terms of the impact of the thinning of shells, or whether that's happening?
That's a great question. I'm actually working on that right now.
Great.
I have a bunch of oysters, and the mineralogy slides I showed you are work that I did. I was visiting a colleague in Scotland and used his fancy microscope for that, and that instrument is being installed today in BioUnit 1, which is just a couple buildings away. So I have the shells, and we're getting them ready. I have an undergraduate in the lab who's getting everything ready, so that'll be going on this winter.
Great.
Yeah, so I can't actually answer your question, but that's a very good question. It's coming soon.
Any other? Yes.
I had a question for Dr. McCoy as well. So you're mentioning a bunch of things, thinking particularly about the correlate algae. If you're seeing a lack of thickness in that, is that potentially a biological or evolutionary response in addition to the climatological response to sort of like reduce the expenditures of just like biological resources to like divert that from shell production to something else?
That's a really good question. Eventually, I think that's what they'll do. These haven't, so they're really long lived. Actually, they live like 30 to like 100 or 200 years. So it's probably actually the same. My hunch is that I have a piece of the same individual that was sort of chiseled off 30 years ago and chiseled off now. So it's probably just like a energetic physiological response, like, oh, I can't do this, so I'm not doing this. People have had mussels in the lab. They're a little bit easier to breed and all that, and they've been doing generational studies on mussels and on urchins. And they do find that after a few generations, that they do reduce sort of the impacts. Interestingly, the urchins start doing just fine, and the mussels, they have slightly different mineralogy, and the mussels in the sort of first generation that's born in the lab actually do the same thing in their shells as what I found in the modern shells. So it's sort of agreeable there. But the evolution is in the lab. You sort of need more time to do that. The mussels that I have from the field are over multiple generations, and that's obviously been a slowly worsening stressor. So I think that evolutionary response would be included in what we're seeing, but I can't separate it out. Yeah.
Okay, great, thank you.
Thanks.
Any other questions? Yes.
Sorry, just a quick follow-up to that question. So when you said you're seeing the generational studies that you're doing, are you seeing a lot, or like, are you seeing a lot less reproduction as a result? Is that what you meant? Sorry.
No, so that's a good question. So the most reproductive studies that people are doing are in urchins because they reproduce pretty quickly. It's actually not affecting what the adults are doing very much in their reproductive success. It's more that fewer of the larvae make it to a stage where they have a lot of shell deformities as they're developing. So most of them don't make it to the end of larval development, and that's actually the most energetic process in their life cycle, so that's probably why. But over time, like the urchins, I think they have out to 3 or 4 generations now, and they see them get, selected for that. So there is hope in the world. And with the mussels, it's the same thing. Some of them look really bad, but others look fine. So there's a lot of variability there, and that's undoubtedly sort of what will be selected for in the future. So it's not as totally gloomy.